So welcome everyone to our BitProject lesson today. We're so happy that you're able to join us. Today's lesson plan is called Strong Structures because we'll be learning about the physics of buildings and building materials. So some of the goals of our lesson today will be to understand the forces, both internal and external forces that act on a building, as well as we're going to be able to draw conclusions on how we can counteract these forces better with proper building technique. So as you can see, this is a structure that we might be able to build later on. And next, we're also going to understand what types of materials actually make buildings strong and how we can best use them. As well as the last thing we're going to learn about is how different types of structures or shapes and designs can actually influence the strength of a building. And we're going to encounter some problems when we make our own buildings, and we'll have to figure out how we can overcome them. So as you saw, the materials on the previous slide of the building of a house with candy. So we want you to have maybe 15 to 20 pieces of candy. They can be gumdrops, jelly beans, marshmallows, any type. So I have some jelly bean type candy and also some square type candy. You can use mini marshmallows or large marshmallows or even Play-Doh, any type of soft candy that's that can be shaped easily. And you can use toothpicks, or if you don't have toothpicks, you could also use dry angel hair pasta. That's the straight type of pasta. And we can also use tape later on as supports if we need to add them. So I'll give you a minute to go collect some of these items if you need. And maybe in the chat, you guys can just type where you guys are from or yeah, what kind of candy you have to use. So I have some jelly beans and some kind of gummy type candy, and yeah. And next, as maybe some of you guys are still getting your materials, but if you already have them, we're going to be talking about different types of buildings and structures. So type in the chat if you have any favorite buildings or if you know of any famous structures around the world. So it could be something you see on this image here, different global buildings, or maybe a building in your city. You guys can type in the chat.
Hey, David.
Yep.
My favorite building is the Empire State Building.
Awesome, yeah, the Empire State Building in New York, once the tallest building in the world, and always an iconic site in the city of New York. Yeah. Yeah, so and that's actually one of the buildings you see in this image here in blue. And other famous buildings that we observe around the world, historic buildings like the pyramids, or even the Eiffel Tower, but maybe more modern buildings like the Seattle Tower or the Twin Towers in Malaysia, and all these other buildings that we observe with different types of designs and architecture that are unique to the region can be found all over the world. And maybe a follow-up question I have is, do these buildings need to be strong? And what features do you think makes them strong? And if you could type in the chat what you think makes these buildings strong. Is it their design? Is it their materials?
I know AK in the chat said that they love the Golden Gate Bridge. Such a cool bridge.
Yeah, the Golden Gate Bridge, definitely an iconic building in California. And I also see Thomas wrote the CN Tower. Yeah, that's another famous building, very tall building as well. So yeah, each of these buildings have their own unique features and things that make them strong. And we're going to learn about more of them in our lesson. So first we're going to have an introduction to forces. So a force is a push or pull on an object. Structures must be designed to resist these forces acting on them. And actually, these forces act upon these buildings or structures every single day. There are two main types that engineers and designers have to focus on, which are external forces and internal forces. So in terms of external forces, these are forces that act from the outside of a building. So that can be weight or what's called load, which is snow or leaves or even people that are standing on top of a building or structure, like a bridge. Second, we have gravity, which is similar to weight, but that's something that is constant. Gravity is a constant force. And then lastly, the third external force is environmental factors. So this can be things like wind, rain, or vibrations, which is earthquakes. So I think many buildings in California are actually designed to withstand small earthquakes or vibrations in the ground. And other buildings, maybe in Asia, are designed where there's more heavy rainfall. So they're designed to withstand rain and heavy wind. So in terms of internal forces, these are forces acting from within the building and usually in two directions or from both sides. The first being, again, weight or load, but this is from objects or people within the structure. And then we have compression, tension, shear, torsion, and bending. And that's a lot of words right there, but we're going to go and define them and see an image of how these forces work. And actually, internal forces, even though it says internal, they're actually usually the result of external forces. So these two forces are not independent, but they actually work together against the building. So types of forces. So the first image here you see is unloaded, meaning there's no force being applied to this cylinder or structure. And we have tension, which is a pulling action, compression, bending, shearing, torsion, and then combined loading. So that's multiple forces at once. So going into detail, again, we said that compression is a pushing force that compacts or squeezes a material. So you see this box gets squished down. So that's what's called compression. Tension is what is the opposite of compression, and that's kind of a pulling force, which you see the box becomes stretched out. So that's tension. So you often hear the phrase tension on a rope, meaning that rope is being pulled. Third, we have shear or shearing force, which is a bending or tearing of a material when they push past each other. So shearing you can think of something sliding past each other in opposite directions. Next, torsion and bending. So torsion is kind of a twisting force, rotating either to the right or to the left. And bending is a combination of tension and compression. So it's on multiple sides of a building, there's different forces being applied. And you can kind of think of bending as when you pull back a bow of an arrow, that's a bending force. Okay, so now we're going to look into the strength of buildings. So we talked about all these different types of forces that buildings have to withstand and are subjected to every day. But what do you think makes a building strong? Or maybe there are some types of materials you would use to build a structure. So one, what do you think makes a building strong? And then two, if you were to make a building, what material would you use?
So AK in the chat said that triangles are stronger than squares and they look cool in a building.
Yeah, triangles are definitely a good foundational shape that we'll learn about later. And yeah, I'm actually seeing the chat again now. And Anonymous said the Space Needle is one of his favorite buildings. And Minecraft Thomas said that they need to be strong and their base needs to be strong, otherwise they'll fall over. And that's very true. Yeah, so those are all great answers and great examples of buildings and structures. So common building materials are things like cement or concrete, wood, glass, metal beams, and bricks. These are all common materials because they're easy to produce. Like wood is from trees, and brick is a combination of materials, but also they have function. Like glass is strong, but also can let light through easily. And then metal beams are the strongest because they're usually the support structures within a building. So what actually determines like the strength of a material? What makes one stronger than another? Why is maybe metal stronger than a piece of wood? That has to do with what we call tensile strength, which measures the force required to pull something to the point where it breaks. So it's the maximum amount of force a material can be subjected to before it breaks. So think about a piece of metal or a material, and you keep on pulling it from either side. At some point, it will eventually break, and that's what's called the breaking point. But how long it takes before it breaks is what's called tensile strength. So something with more tensile strength is a stronger material. And we will look at some types of materials. So again, tensile strength is actually determined by the type of molecules within a material. So we have two main types of categories that we have metals and nonmetals. So metals and metal atoms like iron, aluminum, or copper are common building materials. And then for nonmetals, we have the element carbon, but we also have materials like wood, as we mentioned, which are actually plant cells that have a compound called cellulose, which makes them very strong. Yeah, and as you can see, it depends also on the structure of these materials that determines their strength, and also the type of element. So certain elements have different uses. So like aluminium is used for cans. Calcium is a compound that is found in cement, which is a common building material as well. So metals, as I said, are very strong and have strong tensile strength. This is because metallic bonds are very strong, whereby they're not able to slide over each other. And whenever you actually add two types of metals together, you form an alloy, which is very strong against forces being applied to it because they don't shift or move. So the structure of a metal, in terms of its atoms, is very, very strong and able to withstand forces. That's why many buildings are made out of metal. So next, again, the reminder of tensile strength is determined by the type of molecules. And another non-metal, which is called carbon fiber, also has strong tensile strength because strong carbon bonds form a hexagon structure within this compound, which makes it very, very strong because it's a repeated pattern. And you can actually find this hexagon pattern in honeycombs. That's why honeycombs are very strong in nature because all sides of a hexagon are bonded to another hexagon shape next to it, making the whole structure strong. And in fact, carbon fiber is found in many types of structures and uses in the world. So they're found in soccer boots or sports cars, or even building materials for the engine or chassis of a car, because it's very lightweight and very strong because of its repeated structure of carbon atoms. So lastly, I think as Thomas and others mentioned, that the base needs to be strong so that the building won't fall over. So these are just some examples of different bases that you find in buildings. So some are cylinder, some are square, some are pyramid or triangle, as was mentioned in the chat. And yeah, there's so many different types of buildings, like a twisting structure even, that can be used. So now I'm just going to give you guys a quick minute to go gather the materials again. So you would need toothpicks or angel hair pasta, and you have some sort of candy like gumdrops or jelly beans or marshmallows, and you can also use tape if you like. So I'll give you a minute to go get that, and I'll also just set up my desk so that I can show you guys how we're going to build some of these structures.
I have a fun fact.
Yep, go ahead.
Tall buildings need fast elevators, and recent developments have led to elevators that can travel sometimes up to 30 to 80 feet per minute.
Wow, that is super fast.
That
Yeah, I can imagine, like, if you have a really, really tall building, you need really fast elevators. Otherwise, it takes some time to reach the top. So just give me a moment while I adjust my camera, and hopefully you guys are able to just kind of clear your desk and get the material set out on your table. So hopefully you guys can see my desk currently where I have the materials. So I have these square kind of candy, but you can also use jelly beans or mini marshmallows. Those materials will be fine. And then you need some toothpicks or dry angel hair pasta that you can maybe cut up or break apart. And keep in mind that toothpicks are very sharp on both ends, so do be patient when we're building our structures that you don't poke yourself. And one way to do that is whenever you're inserting a toothpick into the marshmallow or piece of candy, make sure you hold it on the top and bottom and not where your finger is in the path of the pointed end of the toothpick. And don't worry, we can go really slowly with each step, so no need to rush. So yeah, when you're ready, let us know in the chat, and you can even type in the chat what kind of candy or material you have. Is it a marshmallow? Is it like mine, like a gummy candy? Yeah, what are you guys using? And don't worry if you maybe don't have the right type of candy. You can use things like Play-Doh or any type of candy like Sour Patch Kids or whatever you have. And if you really don't have a material, you can always just follow along or just have a piece of paper to draw out some of the structures that we'll be doing in the 3D on a piece of paper.
Anonymous in the chat has marshmallows and toothpicks.
Nice, marshmallows and toothpicks.
Wow, this feels like a really yummy presentation. I might need to go get candy.
Yeah. And your hands can kind of get sticky is what I've realized, so it'll be a fun activity. So first, we're going to actually build our first structure as a simple triangle, as I think was mentioned in the chat earlier, that's a strong structure. So you're going to need 3 pieces of candy or 3 marshmallows or jelly beans and 3 toothpicks. So I have my 3 toothpicks and we're going to form a triangle. So you just need 1 toothpick. We're going to pierce it in like this, and I'm holding it on the edges so I don't poke myself. And you can pierce it all the way through if you like, or just to the center. I'm going to push it to the center. And the next one, I'm going to connect it here. Second one. So I have 2 now. And then to complete the triangle, I'll just poke it through this end. And then combine it with this. That's my second toothpick piece. And then finally, with my third piece, we're going to go ahead and connect that together so that all 3 pieces form a triangle. So there we have a triangle, and I think as mentioned in the chat, yes, it indeed is a strong base. And that's because all sides of a triangle are strong because there's 3 pieces of candy and 3 supports, making each side of the triangle very stable. So the next shape that we will make is a square base. And then we'll need 4 pieces of candy and 4 toothpicks. So here I have 4 pieces of candy, and I'm going to take a couple more. I need 4 more toothpicks. And you guys can maybe type in the chat what's your favorite type of candy. My favorite type of candy is sour candy, so maybe I'll go buy some later. Because yeah, as Umair said, this is making us feel a little hungry. So yep, I'm just building my square base now with 4 toothpicks and 4 pieces of candy. You guys can be careful and just go slowly when you're poking a hole in your candy. And another fun fact about this process, even though we're building 3D models, real engineers and building designers do something similar, but they do it on a computer program. So they use a computer program to build and test structures to see which designs are the strongest. So there's my square. I just gave you guys a little bit more time if you're behind, but again, a square is a strong structure and common in many buildings. You see a rectangle shape or a square shape because all 4 corners of a square are strong and rigid. So if we apply force to it, we see that each corner of the square is strong and able to resist both internal and external forces applied to it, being it twisted or being tension or compression that we pull it or push it. It's able to withstand that kind of force. So next, we're actually going to build a second square because we're going to build a 2-layer structure on top of this original square. So we have square number 1. Now we're going to make square number 2. So again, 4 pieces of candy and 4 toothpicks to build our second layer. And we'll begin to see that we'll run into some problems when we try to make a second layer due to the force of weight and gravity. And we'll see how we can combat that and how we can adjust our structure. So again, we're just making another square structure. Squares are a strong base and very, very common because all sides are strong, able to withstand twisting or compression or tension forces. And another thing that's pretty cool is whenever people build a building, they start with a square foundation, but sometimes they even dig underground to build a deeper foundation or a larger square because that gives the building added stability or weight whenever there's an earthquake, so the building will be on a stable surface. So here's our second square, just like that. And what we're going to do is going to put this square on top of our first square to have a 2-layer structure. So how we're going to do that is with 4 additional toothpicks. We're going to build, so I'm going to insert it at the 4 corners vertically. So I have 1, 2, 3, and 4. Again, just be careful when you guys are placing your toothpicks that you don't poke yourself. And just do everything really slowly. So there I have these 4 support beams sticking out of our base here, and you can think of this as the sides of a building going upwards. And if we want to build a second floor, we have to place that on top of our support beams. So this can be kind of tricky, but just try to do it as slowly as possible. And actually, it can be very difficult because you'll see that the building might actually bend and it might not stand up. So I'm going to try it now, and you guys can follow along. Just try to place your second square on top of your first square support beams. So very slowly, I'll just try our best to place it above and press gently into the support beams. And it's kind of a little tricky, but just try to do one at a time. So you can kind of see that it's our structure's bending and it's maybe giving way, and it's difficult for it to stand up straight. So there's mine, and when I let go like that, it's standing, but give it some time and it's gonna fall over. You can see it's bending, it's bending, it's bending, and you see it's actually leaning. You can see it's leaning all the way over to the right. It's not a very sturdy structure. And when I hold it up like this, now it's back to being a stable structure. And again, we talked about external and internal forces. Maybe type in the chat why you think our building is leaning, or it's difficult for it to stand up. What forces do you think are acting on our building that doesn't allow it to stand up straight? You guys can type in the chat.
Anonymous said gravity, maybe?
Yep, yeah, that's one of the forces, gravity, that is kind of like weight, which is the main force that we see here. And even the weight of our candy. So my candy's a little heavy, but maybe marshmallows are lighter. So because of my candy, the weight of the candy, and as Anonymous said, the weight of gravity, this causes our building to sway or droop because even though we have a square base, the support structures here can't hold up amidst gravity and weight. So there we have that structure here. And we've seen the force of gravity acting on our structure. So you can go ahead and set that to the side, or let it droop or let it kind of lean. The famous building in the world is called the Leaning Tower of Pisa, and it kind of has a lean to it. So I'm not sure if the designers intended that, but I do know that it's also because of gravity and weight that the building is leaning to one side. So next, we're actually going to build a taller structure that does stand up. And to do that, we're going to build some sort of a tower structure. As mentioned, we saw the Seattle Tower. I think Anonymous said the Space Needle, or the CN Tower, Thomas said. So that's kind of a structure we're going to build right now. And we're going to start with 2 toothpicks this time, and a piece of candy. So go ahead and get 2 toothpicks and place them together. So now that we have 2 toothpicks together, this will be a stronger structure. And then we're going to place one at the top here. So 1 piece of candy like that. And then we're going to actually have another 2 pieces. So this will be kind of one piece of our base. And I'm going to do that 3 other times. So get 2 chopsticks together. Oh, not chopsticks, sorry. 2 things together, and then pierce your marshmallow or piece of candy. So now we have 2 structures like that. And then get another 2 toothpicks and pierce that into 1/3 piece of candy. So now we should have these three kind of structures like that. And this will be for our base that we'll use later on. But for now, we will take 2 pieces of candy like this. I'm going to stack it like that, and then pierce 1 toothpick in between both. So I'm actually going to do it on my desk so I don't hook myself and just go straight down to the bottom. So we have something like that. So now we're going to actually, this is our kind of central hub of our tower, and we're going to attach each of these beams, support beams, to the center. And what it's going to look like, I have a finished version here, but it's going to look something like this. So yeah, that's kind of what we're building, a tower structure like that with 3 support beams connecting to our main central hub here of our tower. So much like the CN tower or the Space Needle or other towers have this similar structure. And as you can see, it stands up. But I'm going to build one with you guys here as well. So start with 2 pieces of candy as our central hub, right? This will be the top of our tower. And then just carefully just take 1 support base and pierce them into the center here. That's 1 base, or 1 leg, you can think of it. And then we have our second leg here. And we're going to try to place that into the center as well. And then our third leg right here. Kind of space it out equally in almost like a pyramid or triangle, as that's one of the shapes that we learned is strong in our first structure. So my third leg, I'm going to put it out here into the center like that. So yeah, it might take a little bit of adjusting, but just press very gently. And there we go. We have our structure with 3 legs, and just spread the legs out into a pyramid, so 1 jutting from each side. And yeah, there we go. We have kind of like a tower structure. And you can see it actually stands up amidst the force of gravity and weight because of its stable base. And now we added 2 sticks here, adding its strength. And one thing I want you guys to try as well is what happens when you bring the legs closer together? Does your structure or tower still stand up, or does it fall? So now it's a wide base, but I'm going to bring it closer to see if it still stands. Okay, so mine still stands. And yeah, mine still stands because I guess my candy's a bit wider base. But now, if we apply an external force, so I have another toothpick, and just maybe this can mimic like wind or an external force like an earthquake. So you can see like it falls over pretty easily when I touched it or applied an external force that mimics wind or maybe an earthquake. So maybe you can type in the chat if your tower is standing or how is your building. Did it work better with narrow legs, or is it tougher to stand? And maybe my team members can also help you out as well. So it seems that you guys are able to follow along and able to make your own structures. So yeah, just a reminder that our last structure is able to stand when we have a wider base, because a wider base gives it additional stability. If you can think about when you're in a train or a bus and you're standing up, whenever the bus is moving quickly, you might feel like you're off balance. And if you actually have a wider stance or have your legs spread out wider, that gives you additional balance. So even you see like surfers, when they're on a surfboard, they have their legs spread out wide on the surfboard because that allows them to have greater balance. So similarly with structures, that also applies, and you see towers or buildings that have a wide base with support beams going up the side. So those are the three structures that we kind of built. We built maybe a 2-story square structure that we saw with gravity and weight of the actual candy itself. It kind of tips over. And then we built a pyramid or a triangle base. And we also just had a regular square. So you guys can go ahead and continue to experiment on your own after a lesson plan, after a recap, and maybe combine different structures or try to make a taller tower. See what other materials you can use. Maybe some of you use angel hair pasta, and some of you use toothpicks. Does adding 2 toothpicks make it stronger, or 3 toothpicks? And you can even add tape as support to the edges of your building for added strength. That's something very common in real buildings that have, concrete, cement, and metal all together, because that allows that corner of a building or structure to be stronger when different types of materials are combined together. So yeah, if you guys still have any questions, you guys can put them in the chat, but we'll go back to the slides real quick for a recap of what we learned from our structures. And don't worry, you guys can eat the candy or continue to build your own structures after our lesson. But I'm going to switch back to the slides real quick. Just give me a second. Okay, so hopefully you guys can see my slides once again.
You're good to go.
Yep. So as you can see in this overview slide again, we didn't quite get to build this house structure, but this is another structure you can build with more time. And you can continue to keep going with, if you have a lighter piece of candy like gumdrops, allows you to build a taller structure. And you guys can, see if you're able to do that. And remember that the more wider base you have, or the stronger support beams you have on the side, that will allow you to build a stronger building. So this is instructions, but in the chat, type in what forces are acting on buildings and what are some forces that we observed in our building just now. If you guys have a particular force that you thought really impacted our building, or a force that's common, or going off that, we could think about, what types of materials are strong and why they're strong. So you can type in the chat maybe a material you think that you would use in the future for building your material for your building.
So Anonymous in the chat said that gravity is acting on buildings and weight. That's such a great answer.
Yeah, that's a really good answer. Yeah, correct. That weight and gravity were 2 forces that we saw acting on our buildings, and that's why we need them to be strong. I also see a couple of users said they use Play-Doh for their structures, and one user, Microsoft Java, said that his cube did not fall over. So again, so my cube fell over maybe because the weight of my candy, but if your weight is lighter, then you're able to build a taller structure. One of the materials that we looked at, carbon fiber, is a popular material for race cars and sports equipment because it's very light. It's strong, but it's also very light. So that's probably what you also encountered, a strong material that's also very light. So our last 2 questions we have for our recap is, what types of shapes are the strongest and what kind of shapes worked well with your building.
So Anonymous in the chat said that triangles are the best shape.
Yep, yeah, triangles. So we made triangles and we made a pyramid, which is maybe a 3D triangle. So a pyramid or triangle is common for many towers because it allows it to be a stable structure with a central beam or structure going up the middle. And then lastly, we touched upon it a little bit, but how can we make a building stronger and where should supports be placed on a building? So if I were to put tape on our building or you were to apply tape, where would you put it? Would you put it at the center, at the sides? What do you guys think would be the best? So that's a little bit of a tougher question, and we didn't quite get to it. But supports are like metals or cement or bricks are usually placed in addition on the edges of a building or the sides of a building, because that's a crucial point where the structure is most vulnerable. So when we kind of tested our buildings with a tapping force, we saw that when we tap it on the edge, that's the maybe portion that could cause it to fall or to twist. So supports need to be placed at the edges of buildings. So with that, that comes to the end of our lesson plan, and we really hope that you guys were able to follow along and build some cool structures and continue to try to build taller or bigger structures in your own free time later today, or other types of candy or other types of materials. But yeah, thank you guys so much, and we hope you really learned something today about buildings.